Hey loves, here we are on our third video of the Relationships and Biodiversity Lab. Um, you may be able to hear I am not feeling so great today, so I won't subject you to seeing my face today. And I'll apologize in advance for any sniffing, sneezing, and coughing that may occur during this video. But remember that we have already done, hopefully, the first two parts of the Relationships and Biodiversity lab. So if you go into your Google Classroom, whether you're pink or green, I just happen to be doing pink, whether you're pink or green, you're going to go back to number 9, which should be in your ecology folder. Number 9, relationships and biodiversity. Mine looks different, obviously, because mine is the teacher version, but you're going to open up. You should be able to look at yours and open up your document so that you are seeing this document here. Excuse me. So we left off last time having completed, I had Jen and Cooper helping me out, and we did paper chromatography and the test for enzyme M. So now at this point, if you are looking at this video, hopefully you should already have columns 1 through 5 filled out. So the only empty boxes should be these ones over here. You should have, 4, 5, 6, 7 boxes still empty over here, and that should be just about it. So, what you're going to do for test number, I think we'll do test number 7 first. Let's look at the lab. There we go. So we did test for enzyme M. We did number 5. So let's do number 7, which starts on page 4. So we're skipping number 6 for right now, and we'll come back and do number 6 afterwards. Number 7 is something you've done before. It says you're going to translate the DNA code to make a protein. So the sequence of DNA bases below represents part of the genes responsible for the production of one type of protein, an enzyme produced by Botanicurus and species X, Y, and Z. Under each DNA sequence, write the complementary messenger RNA base sequence that each of these gene fragments would produce. Note, unlike during DNA replication, in the production of RNA, the DNA base A specifies the RNA base U. That's just a fancy way of saying don't forget that when you're going from DNA, which is what this line is giving you in the lab, you're going to write on the first line in your box here, you're going to write the RNA. So I'll do an example with you in a minute. And then underneath that, you're going to have to hit enter, I think, to get it to the second line, but we'll get there in a second. You're going to do the amino acids. So using the universal genetic code table your teacher provides you, which looks like this. I'll attach this to the Google Classroom as well. You're going to use the chart to translate the messenger RNA base sequences into sequences of amino acids in the protein produced by each species. Write the sequence of amino acids under the messenger RNA sequences. So, for example, let's do the mRNA strand first. So I'm going to erase the click to type. It says, I'm assuming that is, yes, CAC. Of course, I'm going to make it a little bigger just because otherwise my line is going right through it. So, CAC. C translates to, C always changes to G. You're going to do your best to line them up underneath. It doesn't have to be perfect. Remember that in this case, A always changes to U because we're going from DNA to RNA. If we were going from DNA to DNA, to the other side of the DNA, G or A would change to T, but in this case, A is going to change to U, and then C again will be G. And then you're going to scooch over. Now we have G changes to C, T changes to A, and G changes to C. Scooch it over. GAC would translate to CUG. TGA. Let's see if I can line it up nicely. TGA would translate to ACU. GGA would be CCU, CTC would be GAG, and CCC, or CTC, again, would be GAG. Oh, I'm going to make the box a little longer. So if that happens to you, you can just make your box a little longer. That may happen on these ones as well. If you make it a little longer, it will keep it on the same row. Okay? So then I'm going to hit enter and hope that it goes down. Yes, it does. Goes down to the next line. So now's where I need the chart. So here's my chart here. I don't know if I'll quite get them both on the same screen, but we'll be able to click back and forth. So G-U-G, the first letter is G. So remember, your first base in the codon here is G. So that means it has to, what you're looking for has to be in this row. The second base in the codon is U. Remember, each of these is a codon. So we have 1, 2, 3, 4, 5, 6, 7 codons here. Not 7 different letters, but a set of 3 letters equals 1 codon. So we have 7 codons. Okay, so GUG, we have GUG right here, and it codes for the amino acid. VAL, which is valine. You don't really need to know that, but you do need to put VAL underneath the GUG. Okay, then we've got CAC. So again, your first letter is C, so it must be in this row. Your second letter is A, so it must be in this column, which means it has to be here in this box. Okay. Oh, that's not what I wanted to do. I don't know what I did. Undo that. Oh, no, don't. Hold on. Undo. And undo. Okay, there we go. I didn't realize I was accidentally writing on it. So right here we have CAC. CAC codes for histidine, which is, again, you don't have to know the whole word, but you just have to write his. Okay, CUC. I'm sorry, CUG is the next one. So CUG is right here. Codes for leucine. So we're going to go over and put it underneath there. LEU. The next one is ACU. ACU. So there it is there. It codes for threonine. THR. THR. CCU. So here we are, CCU. Make sure you don't do CUU accidentally, because CUU would be different than CCU, which is something I would commonly do, because sometimes I mix up my letters. So CCU codes for proline. PRO. And then GAG and GAG obviously should be the same. So GAG, here it is. GAG is glutamine. Or is it glutamic acid? Well, I think it's glutamine. The glutamic acid, I think, is GLN. Sometimes I forget the abbreviations, too. Either way, it's GLU, and same with this one is GLU. Okay? So what I would like you to do is, now that I've done this one with you, I would like you to pause the video, open this picture that I've attached to the Google Classroom, and you can complete species X, Y, and Z. So go ahead and pause. And then when you're ready, come on back and I'll explain to you what you have to do to fill in the data chart. Okay, so now that you should have this all filled in, 1, 2, 3, 4. Remember, we did this first part together, and hopefully you are now have gone through and done the last 3 on your own. You're going to scroll to that data chart page. Make this bigger again. Scroll to the data chart page. Now you'll notice, and again, remember we're doing number 7 first, so we're doing the next column, but they're out of order, so number 7 is the next one. Notice that this box is gray. Basically, obviously, that means you don't have to fill this box in. In the data chart, what you are filling in is comparing the amino acids for X, Y, and Z with the amino acids for Botanicurus. So if you go back up here, that's what you need to be writing in there. So obviously, if I compare Botanicurus with Botanicurus, it's going to be all the same because it's the same thing, which is why they give you that gray box here. So the next box, this box right here, for species X, you're going to compare the amino acids in X with Botanicurus. And notice the column says differences in amino acid sequence. So all you're putting in this box is whichever amino acids from this line here are different than the veil, his, lu, thur, pro, glue, glue. Okay? So you're comparing these sections. Okay? The amino acid to this amino acid. Okay? And then that's for the X box. Not to be confused with the gaming console. So for the Y box, you're not going to compare Y with X. You're going to compare Y with Botanicurus. Okay? So same thing. You're going to be looking at your results here. You're going to compare this row right here, whatever you filled in, with this up here that I did for you, or I did quote unquote with you. I'm hoping you did it along with me. Okay, so that's what will go in box for Y. And then the box for Z, again, same thing. You're going to compare species Z with Botanicurus. So you're going to look at the amino acids, which is in this last row here, the amino acids for Z, and which ones are different between Z and Botanicurus, or BC, okay? So in the data chart, you don't have to write all of the amino acids. You just have to write the ones that are different in X than in BC, different in Y than in BC, and different in Z than in BC, okay? So that is how that one is going to work. Okay, so now that we have finished test number 7, I am going to show you, I'm going to show you test number 6, which is a little bit tricky, obviously, to do. It's kind of like the other ones. I'm just going to kind of demonstrate how we would do it, and then I'm going to show you what to do, have you pause the video, and do your best to do that. So it says on page, the directions for test 6 starts on page 3 of the lab packet. So they're really long, but test 6 is basically the same thing that we did when we did that trouble at Mohan lab, where we had, and if you can see my overhead projector here, we had strips of paper. For you guys, I think for that lab, I had you color them first. I believe we did a color, key, cut rule. So I already have these ones printed on colored paper. So Botanicurus is green, species X is pink, species Y is yellow, and species Z is blue. So what we're going to do is basically we're looking for that specific code, just like we were in the other lab. So it says, to compare the DNA models, scientists use enzymes that bind to cut specific base sequences within the DNA. Remember that this is called a restriction enzyme. That's a really important word. I put this on just a white piece of paper so that you could see it better, but I'm going to write that word out. Restriction enzyme. That's a really important vocabulary word. Okay, so the restriction enzyme is in charge of cutting the DNA at a specific sequence. In this case, we are looking, according to the lab, we were looking for the sequence CCGG, and then we're going to cut between the C and the G. So if I start looking at, let me make this bigger for you. If I start looking at Botanicurus, I'm looking for CCGG. Well, here it is right away, CCGG. Okay, and I'm going to ultimately end up cutting between the C and the G. So I'm going to make a mark there. Keep right on reading CG, but no CCGG. Here we go, CCGG. So here's another one here. And then here's another one here. And that looks like it's it. Okay, so what we're going to do in order to collect the data for this is just like the lab says. It says you're going to use the scissors, which I have, to cut off the quote-unquote white space. Don't worry about that. We don't need to worry about that. So now it says cut the strip between the C and the G, which obviously I am going to do for you because you don't have these at home, nor do I expect that you have printed colored paper, nor do I expect that you necessarily have a printer to print these papers out. So what I'm going to do is I'm going to do the cuts for all 4 of these. And then for the first one, for Botanicurus, I'm going to show you how you put this into the data chart. and how you put it into that very last page, which is basically like your gel. And then I'm going to have you pause the video, and it's going to be your job to do the rest of these just by counting what you see on the screen. Obviously, I am going to cut them for you. So remember that I'm just going to cut off the title here, but it's probably good to know. I should write that down. BC is green, X is pink, Y is yellow, and Z is blue. This way, once I cut the titles off, I don't forget, okay? So now I'm going to go through and I'm going to cut between the C and the G, just like we did in that other lab. I'm just going to scooch these out of the way for now. Cut between the C and the G. Cut here between the C and the G, and the last one is here between the C and the G. Okay, so now you'll notice I have 4 pieces of DNA from the, Botanicurus. Okay, so here's my 4 pieces. Now the next step here, and this is where it gets a little tricky to do it through the computer, but we're going to do our best. Okay, so let's see if I can focus that up a little bit more for you. Well, that's pretty good. Okay, so in class, what you would do is you would count these pieces. You count the number of letters. So 1, 2, 3, 4, 5. I oftentimes would tell you to write the number on the back. In this case, I'm going to write it right on the front. It's a little small, but I'm going to write it right on the front for you. Okay. Then this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to write a 12 down there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So we have a 5. Let's put them in number order. A 5, a 9, an 11, and a 12. Okay. Oh, I screwed it up. Sorry. So a 5, a 9, an 11, and a 12. If I scooch this back over, and we go to the very last page of your lab, this page, which is not a page we've done anything yet with. Here's what this page looks like. And you can see that it says, again, this one's the same as this one. Be extra careful not to delete the whole picture. But you'll also notice that each and every one of these teeny tiny little boxes has a box in it that I put in it. So this is like your big piece of construction paper. For the Trouble at Mohan Lab, you took that piece of construction paper, you labeled it across the top with your things. In this case, it's species BC, species X, Y, and Z, and then you numbered it down the side. Remember that DNA is going to move through a gel in at a certain speed. The smaller pieces, so the pieces that are only 1, 2, 3, 4, 5, etc. Letters long, the smaller pieces are going to move faster, so they're going to get closer to the bottom or closer to the positive pole than the larger pieces. So here we have 4 different pieces. I'm going to zoom in on this a little bit. I want you to pay attention to how I fill this in. Okay, so I'm just doing Botanicurus right now. Botanicurus, I have one that's 5 long. So what I'm going to do to simulate that, and again, it's already been set up for you, but just be careful not to delete the boxes. Hey, undo that. Oh my God. Go back to where I was. Sorry, I'm too zoomed in. So you have to be careful not to delete the boxes, the big paper or the, these tiny boxes that are all in every spot, okay? So here's how you're going to do this. For Botanicurus, see over here we have a 5, a 9, an 11, and a 12, okay? I'm going to take the 5. Normally, in real life, you'd take this little piece of paper and you tape it down on top of the lab, right here under Botanicurus for 5. Obviously, because we're doing a digital version of it, we can't really do that. I can't figure out how to take this little strip of paper and tape it onto my computer screen. But what I can do is take this box and I highlight this box, and now I want to go up here, and you're going to hover over these things. You see this one here that says fill color. That's what you want. Fill color. And this one I'm going to do green because it's a green piece of paper. And look at that. It fills the color. Okay, so you have a band there. The next one I have is a number 9. So I'm going to go up to the number 9, click in that box, and do the same thing. Fill color. I'm going to stick with the green. Okay. Number 11, or the next one is a size 11. So I'm going to go up to number 11 here. Again, fill color, green. And the last one is a 12, so I'm going to go to the 12 box, same thing, fill color, green. So what you will start to see is a banding pattern. There's your bands for Botanicurus. Now what I'm going to do is go back over here. I'm going to switch the screens, and I'm going to cut all the rest of these for you. And I'm going to leave them on the screen for you. So you're going to pause the computer, or you're going to pause the video, and you're going to count your letters. And then you're going to come over here, and you're going to color in your boxes. Okay? So I'm going to do that for you. And then you can pause after each one, and I'll line them up the same way. I am going to ask that you count them yourself, though. So I'm not going to count them for you because I'm not asking you to do a whole lot else. So I figure at least I could ask you to count to no more than what? 24 is the highest number? Yeah, you won't be counting higher than 24. So now we do species X. Species X. We're still looking for CCGG. So here's CCGG. Forget the fact that this is also a G. It doesn't matter that this is a G also because all that matters is these 4 letters. That is all that makes the difference, okay? It doesn't matter what's on either side of them. Okay, so we're going to cut there. Here's another CCGG. We're going to cut here. And that looks like it might be it for that one. So there's only 2 cuts for this one. So I'm going to trim off the edges again, just like I did for the green one. And trim off the name Species X, but I wrote it down. So remember, Species X is pink. And then I'm going to cut these for you. Right here and right here. I actually am going to cut this. I'm going to count this long one for you because I think sometimes the longer ones are harder to cut. They're harder to count, especially if you're counting on your computer screen. So I will count the long one for you. I'm not counting those short ones, so you're going to count the short two. Okay, so let's zoom in. They're all in size order, I think. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, I'm going to put a 22 right up there. Okay, so for this one, because I love to color code things, it doesn't really matter, but I would like it this way if you want to do it this way. When you're doing it, again, this is species X. You're going to zoom in just a smidge. At least I like to zoom in just a smidge. And for 22, you're going to do it in the column for species X because it's the pink one. You're going to go to the 22. You're going to click on the box. Same thing. You're looking for fill color. But of course now, because I love to color code things, instead of using green, I'm going to use pink. Okay? Your call. You can use whatever color you want, but I just really like it when it is color coded. Okay? So go ahead and pause the video. You're going to count each of these two. How many letters there are in this one and how many letters there are in that one, and then you're going to come back over here and put your bands. So obviously for pink there should only be 3 bands, even though for green there was 4 bands. So go ahead and pause right where that's at. Okay, so now that you have done pink, the next one is species Y, is yellow. Scooch out again, make it a little bigger again. This one, you're really counting this one all on your own, I swear. I'm not doing it for you. We'll cut the ends off. Put that off to the side. Okay, and again, what code are we looking for? Hopefully by now you remember we're looking for CCGG. So here's a CCGG here. Cut. CCGG. Again, CCGG here. Cut. This doesn't matter. It doesn't matter if it's C, an A, a T. It doesn't matter. It's all about from here to here. That's all that matters. Okay. CGC doesn't count. CCCGG, this counts, but only this part. Again, this part doesn't matter. It's just what's in that box that matters. So we'll cut there. And that looks like it's going to be it. So we got a couple of little pieces here. So we cut here. We need to cut, right? Did I cut it? Yeah, I did. Okay. And I just messed it up. Who's a call, man? I'm going to have to start over. We'll cut there. And we'll cut there. Okay. So again, I'm going to zoom in on these for you. I'll put them into order, and your job is going to be to count them. And I'll zoom in so they're a little easier to count. You can go ahead and pause the video, and then count, and then you can put them here. And of course, I really like, again, you don't have to, but I would like it if you did. So for example, this one's obviously 3. I'm not counting anymore, I swear. I'm not counting, you're counting. What are you talking about? I would like it yellow. Okay. Okay, so the last one, you can always remember to pause the video and unpause the video. There's no sense in me sitting around staring while you do it live. This one, species Z, is blue. Okay, so again, oops, sorry. Come on. Oh, wow, that was fancy. We're looking for CCGG. Sure, I don't know that person. So, looking for CCGG. We'll cut right there. This is CGC, but here's CCGG, so that counts. We'll cut there. CCGG, here's another one, and we'll cut there. Okay, so looks like we'll have 3 cuts for this one as well. And cut. And cut. Okay, this one looks like the longest, the next longest, the next longest. So we'll zoom in on those for you. Let you pause your video. So we can scooch that back over. And then again, now you're doing it into blue. The blue one is for Z. So you can pause the video. And same thing, you're going to click into whatever boxes you need to click into. This makes it a little harder, just because, for me at least, just because if I zoom out, I feel like it's too hard to see. But you can, oh yeah, you can see. Okay, so if I zoom out, it's a really, I mean, you gotta have really good eyes to see the numbers here, but you can still totally click in these boxes. The bottom one here is 1, 2, 3, 4, 5. I'm not counting, you're counting. This looks like a 5 to me, right? 1, 2, 3, 4, 5. So again, because I'm a nut job and I like to color code things, I would make it, do I want cyan or count? No, I'll do cyan. Cyan, whatever. We'll make it that color blue. Okay, so go ahead and pause it. You can fill in the last couple there. So now, the last thing we have to do here, we're done with those. The last thing that we have to do here is go back and fill in our data chart for number 6. So all you have to do for filling in the data chart for number 6 is, which is, again, the last column. This should be the only blank column you have now. Everything else should be filled in. The last thing you have to do is the gel electrophoresis banding pattern. So for each of these 4 boxes, you're going to all you have to do, it's a magical thing. You just have to write in the numbers, okay? So for example, we did Botanicurus together, so I'm going to do that one. So my numbers for Botanicurus were 5, 9, 11, and 12. Those are my numbers, 5, 9, 11, and 12. That's where I have the bands. So in the box here for Botanicurus, I'm going to write 5, that's an 8, 9, 11, and 12. And then you can go on to the next one, whatever you got for species X. I know we have at least 122 for species X. So there should only be one of each number. by the way. Okay, so you're going to put a 22 and whatever other numbers you got there. And same thing for Y and same thing for Z. Once you've completed that, this whole chart should now be completely filled in. Okay, if it's not, then go back and watch the videos again and make sure that you have done all of this stuff. Please make sure that you have done this before you start the fourth video. If you have not finished this data chart, it will be very hard to do the fourth video, which I haven't even made yet, but I will. Okay? I hope everybody is doing well and feeling well and staying safe. I hope this blah weather isn't making you too blah. And hopefully I'll see you guys soon. I am live on the 2-day, which this week, which is the week of April 27th. The 2-day is Tuesday, Thursday, and then next week, the week of May 4th, it looks like. The week of May 4th, I will be live Monday, Wednesday, Friday. Okay, good luck. Let me know if you have any questions. Bye, guys.